Okay, so today we are going to talk about roots and zeros, and we're going to be using more synthetic division today. So we're going to have to recall some of the things we learned yesterday to help us make sense of this process. So we are going to learn about the fundamental theorem of algebra, which I really already gave you a preview of. And then we're going to determine the number and types of roots to find zeros. Okay, so before we were just finding zeros with factoring, and that means that all of the zeros had to be real numbers. Okay, but you are going to have zeros that are imaginary or that can have radicals in them. So the fundamental theorem of algebra tells us that every polynomial function of, and they call it just degree n, okay, some unknown degree, that has exactly n roots or zeros. Okay, so we have talked about this before. Remember we said if the degree is 4, you should have 4 zeros, 4 solutions. So that is going to include something called multiplicities, which we're going to talk about today. Okay, as well as real and imaginary zeros. Okay, so every quadratic function, what is the degree of a quadratic function? Quadratic function is x squared, so what's the degree? 2. So every quadratic has 2 roots. Okay, every cubic function has how many? 3. Quartic has 4. Okay, so on and so forth. Okay, so sometimes you're going to have a multiple root. That is just a root that appears more than once. Okay, and there's a few different ways that you can run into a multiplicity. Okay, the multiplicity of a root is going to be the number of times it is a factor. Okay, so if it has a multiplicity of 2, it means the root occurs twice. So it is the number of times the root is a 0. Oops, forgot my R. Just going to redo that. Is a 0 or a factor. All right, so we're going to go over an example that I briefly mentioned in a previous lesson. So one way you can have a multiple root is if you have something like this. If you have 3x cubed equals 0, okay, if it's to the third power, we should have 3 roots. But if we solve this for x, we're going to divide both sides by 3. Okay, we get x to the third equals 0. And then we would take the cube root. Okay, when you are taking that cube root, that means this 0 occurs 3 times. So we would write x equals 0 with a multiplicity of 3. Okay, if it was the 4th root, it would be a multiplicity of 4. Okay, another way you can get a multiplicity is if you have the same factor. So if you have x squared plus 8x plus 16 equals 0. Okay, let's go ahead and factor that. It is a perfect square trinomial. Okay, so you can do x plus 4 times x plus 4. You can also do x plus 4 squared, but when you take the square root, it would be that 0. So if you're setting both of these equal to 0, okay, you would get x equals negative 4 and x equals negative 4. Okay, so that would happen twice. So you can just say x equals negative 4 with a multiplicity of 2 because it happens twice. Okay, if you left it as the square and then took the square root, that means the 0 would happen twice, and then you would add the 4 over. Okay, so it is nice to see it out that it's going to happen twice here. Okay, so you are going to solve each equation. So when you're solving, you are finding those roots, and then we're going to state the number and the type of roots. Okay, so the type of roots means, is it real or imaginary? Okay, so if it says find the type of roots, it's real or imaginary. Okay, and then the number would be like, are there 2 roots? Are there 3? Are there 4? Are there 5? Okay, so how many there are. All right, so for A, we have x squared minus 8x plus 25 equals 0. Okay, so this is a quadratic. So to solve a quadratic, we can try to factor. If it doesn't factor, we can use the quadratic formula. Okay, so what are the only things that multiply to 25? 5 and 5, 1 and 25, and they both would have to be the same sign. So they're never going to add to negative 8. 5 and 5 will be 10. 1 and 25 will be 26. Okay, so if you can't factor it, we are going to use the quadratic formula. So you have your A, your B, your C. Okay, so I want you to go ahead and do the quadratic formula right now. Okay, if you want to work with your row to do that, you can. Yeah, no calculator. So really work on that simplifying. Okay, so when you are deciding how to solve something, okay, if it's quadratic, that's the only time you can use the quadratic formula. So if it was x to the 4th, you could not use the quadratic formula, okay? And you can try to factor no matter what it starts with. This is not factorable. Okay, so can you factor? No. Can you use the quad formula here? Yes. Could you use, oh, you can't see it yet. We'll talk about it in a second. Okay, so if it's x to the fourth, you cannot use the quadratic formula. Okay, so once you know that you can use it because it's x squared, you're going to do the opposite of b, plus or minus b squared minus 4ac. Okay, and then 2a. All right, so we know 4 times 25 is 100. So 64 minus 100 is going to give you what inside your radical? Yeah, what did you guys get? Negative 36, right? Okay, so if it's a negative, you're going to have to bring your I in with it. So you have 8 plus or minus 6i. When you divide by 2, remember that applies to both terms. Okay, so you should have 4 plus or minus 3i. Okay, so those are two roots. You have the positive and you have the negative. You don't have to write them out separately, but understand 4 plus 3i is one of the roots, 4 minus 3i is one of the roots. So state the number and type. So the number, there are 2, and then because you have the I, there are 2 imaginary roots. Okay, so the solving each equation is the first part, and then the number and type of roots is the second thing we're going to identify. Okay. All right, so here we have x to the 5th minus x cubed minus 6x equals 0. Okay, you cannot use the quadratic formula here because it's to the 5th power. So the first thing I would always try to do here is factor. And when you factor, remember, the first thing you look for is what you have in common. Okay, so you can definitely factor out the GCF. So start with that GCF. Okay, and then adding what is the GCF for part B? Yep, so we're going to take out the x. Okay, and then Rocco, tell me what you're left with once you factor out the x. Good. Okay, so now we're going to try to break this down. So keep that x on the outside, don't lose it. You have your x squared and x squared has to multiply to negative 6. It has to add to negative 1. So go ahead and find what two values multiply to negative 6. That add to negative 1. Okay, and then Cam, will you tell me what you got for those?
I got 3 and -2.
That, I thought you put,
-3.
yeah, -3 plus 2. Yep. Okay, so negative 3 plus 2 will be negative 1. Negative times positive is going to be a negative. Great. And then from here, you can use your zero product property. This is just like what we did when we were factoring in 5.2. So we're going to set x equal to 0, x squared minus 3 equal to 0, and x squared plus 2 equal to 0. Okay, we're going to solve. So x equals 0 is already solved. Okay, I want you to go ahead and solve the other two based on your prior knowledge. And then we're going to write all of our zeros together, and then we will classify them. Okay, again, don't forget when you take the square root, you have your plus or minus. Our Yoda meme today reminded you of that. There is another one, not just the positive. Okay, so when you take the square root, if you have a negative inside, it's the I that has to come on the outside, and you can't simplify the square root of 2, so you're going to leave it. Okay, so your zeros, remember you should have 5 of them. You have 0, and then plus or minus root 3, and then plus or minus I root 2. Okay, so you have 5 altogether, and then we're going to state the number and the type. All right, so of those roots, okay, you are going to have 2 that are imaginary. Okay, and you are going to have 1, 2, 3 that are real. And you only need to classify if they are real or imaginary. You don't have to classify if they're rational or irrational. We did talk about that when we did the discriminant. Okay, 0 would be rational, these would be irrational in the root. Okay, but all you have to do is identify the imaginary and the real. Okay, so it'll only be imaginary. There's a negative inside the square root, and you have that I. Okay, now there are some special root theorems about roots that come in pairs. The first one is the irrational root theorem, okay, which tells you if you have a radical in this form, a plus b root c, okay, if that is a root of the polynomial, then its conjugate, which would be a minus b root c, is also a root. Okay, so if you look here, you have the I root 2, okay, and the negative I root 2. So those are conjugates. It would just be their A value is 0, and that can happen. Okay, sometimes your B value is 1, and you'll just see the radical. That can happen too. And then the other one is the complex conjugates theorem. And that says if you have a plus bi as a root, then its complex conjugate, a minus bi, is a root. Okay, which is similar to this. If 4 plus 3i is a root, 4 minus 3i is a root. Okay, so I'm going to have you complete these examples. Okay, so if 2 plus root 3 is a root, so is, and I want you to fill in the blank. And then this one, I'm just going to give you the value, and I want you to tell me what the conjugate is. It's called the conjugate. Okay, so give those a try. If you want to write it in pencil, if you don't understand it yet, that's okay. Okay, and then go ahead and try the complex conjugate. Okay, conjugate to help in just a moment. All right, so Dina, can you tell me what you were thinking for this first one? If 2 plus root 3 is a root, what else would be a root? So you want to do it as the opposite of this. So if you have the plus value, you're going to use the minus. So if it's 2 plus root 3, it's going to be 2 minus root 3. Okay, and then Lawrence, what did you put for number 2? Good. Okay, so sometimes people aren't sure what to do with the negative in front. Notice here, if this is A, this is still A. Okay, so even if A is a negative, it's going to stay negative here. The only thing that changes is the sign in the middle. So negative 1 plus 2 root 5. Okay, and then Titan, can you tell me what you put for the, if negative 2 plus I is a root, so is what? Yeah, negative 2 minus I. So again, if it's negative in the front, you're going to keep it, and then that's just going to be the opposite. Okay, and then Ian, what'd you get for 1 minus 3i? What's the complex conjugate?
1.
Yep. Okay, so your values stay the same. It's just that sign in between that's going to be changing. Okay, so we are going to be using our graphing calculators today for the back. Okay, we're going to find the x-intercept using a graph rate table. If you don't have your graphing calculator, you can use decimals on a Chromebook today. Okay, but you're going to need this for your first step, okay? So the first thing we're going to do when we are finding all zeros, we are going to find the x-intercepts, and you can either use your graph or your table or both. Okay, and then once you find your x-intercepts, those you can verify using synthetic substitution. Okay, so you're going to use synthetic substitution to verify those roots, because yesterday we learned that if you have a remainder of 0, it's a factor. Okay, if you have a binomial that's a factor, it also means that when you set that binomial equal to 0, that value is a root. And then they call this that you're going to create the depressed polynomial, which is just 1 degree less. Okay, so it's because you're dividing. Okay, and you're going to keep doing that until you get a quadratic. The reason why is because you can always solve a quadratic with the quadratic formula. Okay, so you want a quadratic polynomial, and then you are going to solve that by setting it equal to 0. So you're going to use the skills we talked about in our example today and what we did when we were factoring earlier in the unit. And then you're going to identify all of your roots and zeros. We know that the degree is going to be equal to the number of roots. Okay, the degree is the same thing as the highest exponent. Okay, so once you get a quadratic, there are a few different ways that you can solve it. Okay, there are times where it could be factorable. Okay, there are times when you could just solve. And there are other times where you're going to use the quadratic formula. You might be able to solve with a square root. Okay, in some cases, you might be able to factor to solve. It all depends on what quadratic you have. Okay, so when you are doing your practice today, it asks you to sketch a graph. You don't need to sketch the graph, okay? You're going to need to do your graph to find the x-intercepts anyway. So you can just follow these steps above. So the directions are just going to say find all the zeros using synthetic substitution. So you have to make sure you are verifying with your synthetic substitution. So for part A, we have x cubed minus 2x squared minus 2x minus 3 equals 0. Okay, and we know our final answer is going to be 3 zeros. So that's your degree, that's what you're going to find. Okay, so in step 1, we are going to graph and we are going to find those x-intercepts. So let's go ahead and do that now. So on your graphing calculator, in your y equals, we can do, oops, I put it in there. Okay, so x to the third minus 2x squared minus 2x minus 3. Okay, and to get it back to your standard window, you can just go to Zoom, Standard, and you are looking for where it crosses the x-axis. So this one's pretty clear, it's at 3. You can always verify that with your table, because at 3, you should have a y value of 0. Okay, and then we're going to use synthetic substitution in order to break this down. We can't factor by grouping because if we tried to factor this by grouping, you would not get the same binomial and you couldn't go any further. So you do need to use the synthetic substitution. Okay, so if your x-intercept is 3, that's what we're going to put on the side here. And then just like we did before, we're going to use the coefficients, and we're just going to be mindful of any placeholders. So x to the third, x squared, x, and then my constant. Okay, so we talked about yesterday, if you have the remainder of 0, we know this is a factor. This also means it's an x-intercept, this value. Okay, so 1 times 3, add straight down. 1 times 3, add straight down. Okay, so we do get a 0 here. So what we just did is we confirmed that 3 is a 0. If your remainder is 0, whatever you use for your synthetic substitution is a 0. Okay, so now we are going to write this as a quadratic. And step 3 says we are going to solve that quadratic. Okay, you can always try to factor, but if it multiplies to 1 and adds to 1, it's impossible because 1 plus 1 is going to be 2. Okay, so we are just going to go ahead and use the quadratic formula. Okay, and I usually write out like my A, B, and C, but they're all 1s here, so you don't necessarily have to. Okay, so I want you to plug that into the formula and see if you can simplify. All right, and then just keep in mind that when you're using that quadratic formula, that plus or minus is going to give you 2 of your zeros there. Okay, so you should have a total of 3 zeros. Okay, so your zeros are 3, and then negative 1/2 plus or minus. You can either write it like this, where the I is on top, or if you want to write it where the I is on the side here, that is fine too. Okay, and that is going to be your final answer. Okay, so this was a cubic function. This polynomial was a quadratic because it was 1 less. Sometimes you're going to have a larger polynomial like this one. You have x to the 4th minus 3x cubed plus 5x squared minus 27x minus 36, and that is equal to 0. Okay, so keep in mind your final answer should have 4 zeros because that's your degree. Okay, that's your fundamental theorem of algebra. Okay, so the first thing I want you to do is I want you to find the x-intercept. Okay, in the first one we only had 1. Sometimes you're going to have multiple. Okay, so if there's more than one, I do want you to write all of them down. Okay, so for your x-intercepts, you're just seeing where it crosses your x-axis. Okay, so you have 2 places. If you want to verify those with the table, you can. If it's an x-intercept, the y is going to be 0. So you have one at 4, and you also have one at negative 1. Okay, so you have 2 x-intercepts here. Okay, you have negative 1 and you have 4. Okay, so when you are doing this in step 2, you are going to choose one of those x-intercepts, and it really does not matter which one. Okay, so if you want to do negative 1 first, you can. If you chose to do 4 first, that is fine. Okay, and then we're going to line up our coefficients. Remember to give yourself enough space so that you don't smush any numbers together. Okay, so go ahead and do your synthetic division. Okay, so 1 times negative 1 is negative 1. Add straight down. You get 4, negative 9, negative 36, 36. Yay! Now, if we were to create the polynomial, okay, this is your remainder, your number, your x squared, your x to the 3rd. Okay, this is a cubic function. What you really want to do is you want to get down to a quadratic. Okay, so in order to do that, you have to use these coefficients in your next synthetic division. Okay, so use these as coefficients. to get a quadratic. You can't use the same polynomial again because the polynomial, the depressed polynomial, is always 1 degree less. So if you have x to the 4th, if you use those, you always get x cubed. Okay, we want x squared. So what we're going to do is we are going to use these as our coefficients so that we can get a quadratic. And we've already used a -1, so now we have to use the other x-intercept. Okay, so if you have x to the 4th, it's good that you have 2 x-intercepts because you're going to have to use both in order to get your quadratic function. Okay, so go ahead and do your synthetic division from there. Okay, so then 1 times 4 is 4. That makes 0. This is 0. Okay, so this is your remainder, your number, your x squared. So if you write out the quadratic, you have x squared plus 9 equals 0. You could absolutely use the quadratic formula, but that might take a little bit longer in this case. If you don't have an x term, you can just subtract 9 from both sides. Get x squared equals -9, and then you can take the square root. Okay, remember that you do need to show your square root steps. And if the square root of 9 is 3, the square root of -9 is 3i, okay, with your plus or minus. Okay, so then when you are listing your zeros, remember you should have 4. So once you confirm that is 0, okay, both of these are going to be part of your zeros. So your zeros are -1, 4, and plus or minus 3i. Okay, this process that we just went through is always going to work. You can always use that x-intercept to bring that down to a quadratic. Now this one is special. This doesn't happen all the time, but it does happen here. So just in case you guys were thinking about this cubic function, this cubic function is factorable. So that does happen. If you were to factor this by grouping, you would take out what they have in common. And you could use this method as well. Okay, so you would get x squared plus 9 times x minus 4 equals 0, and you could solve both. Okay, x minus 4 would give you 4, which is what we found with synthetic division, and then this would be the same as step 3. Okay, that does work sometimes. It is more rare than being able to use that. But if you do notice it and you want to solve it that way, you are welcome to. Okay? All right. So we've done a degree 3, we've done a degree 4. Let's do a degree 5. Okay, and technically if you did want to factor out the GCF, you could. And then you'd have to do the same steps with your x to the 4th. Okay, I'm not going to do that. I'm going to find my x-intercepts.
is it?
Okay, now for this one, it crosses multiple times, okay? You can see a few of them are not exactly on the line. That's okay. The reason why these did not have other ones on there is they were imaginary, and imaginary zeros are not on the graph, but you can have an irrational zero that will show up on the graph, but it's a square root, so you have to find it with the quadratic formula. Okay, a good thing to do is verify with your table. So I can see at 0, I'm at 0, okay, and at 2, I'm at 0. So we're going to start this the same way we did with the last one, okay? We're going to do the coefficients. I'm going to show you something to make just the writing out of this a little bit easier, so just don't skip too far ahead of me on this one. And then remember with your placeholders, it's if you have anything missing. So you have 1x to the 5th, negative 6x to the 4th, 8x cubed, 8x squared, negative 16x, and then you are missing the constant term. You do have to put a placeholder in there for the constant. Okay, so even if the constant is missing, you need your placeholder. Yep.
If you factor out the x first, you have to keep the x.
No, because if you factor out the x first, you would only be doing synthetic division with your x to the 4th minus 6x cubed plus 8x squared. Your polynomial would be different. Let's finish this one first, and then we can go look at that part. So when you bring down your 1, okay, and again, it doesn't matter which one you use first. We're going to do the 0. So this one should be pretty quick. 1 times 0 is going to be 0. Okay, you get negative 6 times 0 is 0. Times 0. Times 0. Times 0. Okay, and then what you have here would be a quartic. So we're going to want to bring that down one more time. Now, I told you I was going to show you a way that you could save space. If you want, you can just make the second one from here. Okay, and you can put the 2 here. So you can just kind of add that on as you're doing the synthetic division. And then you don't count the 0 anymore. So 1 times 2 would be 2. Add straight down. Okay, and then you would get 0 here. Okay, and then this is a cubic function. Okay, and there's, you could try to factor this. There'll be nothing that will multiply to 8 but add to 4. So we really want to do this one more time. Okay, but you only had 2 zeros. So earlier today we talked about a multiplicity. Sometimes on your graph, you can see there's a multiplicity because it won't go through the x-axis. So we wrote down 0 and 2. If you look at 0, right, see how the line goes straight through the x-axis? That means it's just a multiplicity of 1. There's no extra zeros there. But look what happens at 2. You see how it touches the axis and then goes back? When that happens, that means the 0 happens more than once. And so 2 happens twice. So we're going to use that again. Okay, so we are going to use 2. It won't work again unless it is a multiplicity. Okay, and we're going to write just a little note down so we know to check for the multiplicity. Okay, so I'm just writing down exactly what I told you. If you run out of zeros, you want to check for a multiplicity on the graph. Okay, so the way that you check for that is if it touches the x-axis but it doesn't go through, okay, then it's most likely going to be a multiplicity of 2. Okay, and then that means now you have your quadratic. So once you have your quadratic, you can go to step 3 and do 1x squared minus 2x minus 4 equals 0. Oh, you're just writing it from here.
Oh.
Okay, so this will be your x squared. This is your x squared, your x, and then your number. And then I want you to do the quadratic formula with that. So you're just going to set that polynomial equal to 0. So it's just a 0 that happens more than one time. So it's when you're factoring, you have 2 factors. So it's like this. You know how sometimes you factor and you get the same one twice? That's what's happening there. So if it was 2, it means when you could factor it, be x minus 2 times x minus 2. All right, and then if you do x equals the opposite of b plus or minus b squared minus 4ac, be careful when you have the 2 negatives because that means you're going to be adding. Okay, so if you have negative 4 times negative 4, that's going to be 4 plus 16. So you have 2 plus or minus root 20 divided by 2. And then we always want to simplify when we have perfect squares in the radical.
Please excuse the interruption. Teachers, at this time, if you have not already opened up your email to share information about the gift giving project, please do so at this time. Thank you.
All right, so then we'd have 1 plus or minus root 5. Again, you would simplify here. If they're in front, you can simplify those together. And then when you're writing out your zeros, you would write 0, 2 with a multiplicity of 2, and then 1 plus or minus root 5. So it'll be 1, 2, 3, 4, 5. That would be your total number of zeros. Okay, now there was a lot packed into that example. Okay, that combines a lot of different things. You aren't always going to see all of those different things. And then if you did do the factoring first, if you factor out that GCF, your process is going to look almost identical to what we did. The only difference is, remember how we set each one equal to 0? Your x equals 0 you would get from here, and then you would do the synthetic division with this. So when you do the synthetic division with this part, okay, look at the coefficients. Do you see how it matches here? The 1, the negative 6, the 8, negative 16. So what you would have for your synthetic division is just this part. Everything else would be the same. It's just instead of doing 0 with the synthetic division, you have to get it from here. Okay? All right, so, yeah. How about this?
Yeah.
Okay, yeah, go ahead.
On the first example we did, the one where A, B, and C all equal 1, wouldn't the B be negative 5? Like, go back to the first example.
You said A, B, and C were all 1. First example on page 1 or part A?
Part A.
Yeah. So if it's a negative times a positive times a positive, you're going to subtract. So it'll be 1 minus 4. That's how you get
Oh
the
no,
number.
I was confused on something else, but
Okay.
I just wrote it off on my notes.